IDC analyst, Brad Casemore, who is a director of research for data center networking. And also joining us is Jeff Hussey, the CEO of Tempered Networks. And Jeff was also the founder of F5 Networks. And today we're going to kick it off with Brad talking about IDC's perspective of networking for the third platform. And I'll hand it over to you, Brad.
Thanks, Elaine, for that kind introduction. Yes, my name is Brad Casemore, and I'm Director of Research for Data Center Networking at IDC. And today we're going to talk with you, I'm going to cue it up by talking about what we're seeing happening in the marketplace involving networking for the third platform. I'll explain what the third platform is. I'll take you through it. I think one of the important things that I want to say off the start is we're witnessing significant change in networking today, extending all the way from the data center out across the campus and the WAN. It's a period marked by innovation. It's a period marked by opportunity for customers and vendors alike, but it's also a period of notable disruption, and I'll go over why in this presentation. And here on this slide, I want to talk about digital disruption. Organizations today are adapting to changes in their ecosystem, and they're doing it by leveraging digital technologies. They're trying to create new customer experiences. They're trying to improve operational efficiencies. They're trying to generate new revenue, and they're trying to respond to changing conditions. I think what they're really doing when you think about it, and one of the ways I like to describe it is they're going from systems of record to systems of engagement. So from the back office systems that were used, of course, in the past to being far more engaged with customers and using IT rather than being support infrastructure for the business to being a frontline enabler of business agility and business results. So if we move to the next slide, the move to digital transformation really occurs on something called the third platform. And I said I'd define that for you, so I will right now. The third platform comprises cloud, comprises mobility, comprises big data analytics, and to a lesser extent social business. And on the third platform, you have a bunch of innovation accelerators that reside just atop it. And that includes a lot of next generation security and includes those other things there, as well as the Internet of Things. And digital transformation is occurring across all industries right now. It really doesn't matter what your vertical is. It's an imperative probably for the businesses that you're in today. And it's going to be a very significant imperative for years to come. And it really is predicated on that third platform that I just defined for you. If we move to the next slide, one of the key elements of the third platform, as we discussed, was cloud. And cloud today is becoming increasingly important to enterprises worldwide. This data that you're seeing here is from a study that IDC does every year. It's called the Cloud View Survey. And as you can see, we did it again early this year, and we had a number of respondents worldwide who provided answers here. And we can see that the data here, we can see that 80%, nearly 80% of respondents indicated they're embracing or deploying cloud. A smaller percentage were evaluating, and only 8% were not interested. So cloud is pervasive. And as you can see the definition there, describing their organization's current or near-term plans to use public cloud or private cloud to support production workloads and services. So cloud, definitely, I think we all know it's taking off, but here's some hard data to support that. If we move to the next slide. So we talked about the third platform and what it comprises and how it's really driving a lot of change today. And here you can see some stark numbers that really relate to third platform ICT spending relative to second platform ICT spending. And you can see that the growth obviously is in third platform ICT spending. We've got through 2020, through the forecast period indicated here, third platform ICT spending growing at a CAGR of 12.7%, while second platform spending is 4.8%, minus 4.8%. So it's contracting over this period. The growth is really in new applications, and it's in new infrastructure that really supports those applications. if we move to the next slide, we can see that, we've talked until now about, the third platform, about cloud, about some of the drivers for what's happening, but now I think it's important to kind of look at networking and how networking has to change to enable these new workloads. We've seen really a generational progression from what we would call the first period or the first platform, which was all about mainframes and mini computers and networking them. And we had things like ARPANET, we had all kinds of circuits, and we had early hubs, and we had technologies like Token Ring back then. Then we moved into a second period for the second platform, which was all about client-server computing, primarily north-south traffic. There we saw Ethernet switching first come about, multi-protocol routing, LAN-WAN technologies, TCP, and of course, now we're moving into this third period, which is all about networking for not only virtual workloads and workflows, but big data. We have hyperscale web, we have containers and microservices, we have DevOps, we have a proliferation now of east-west traffic, and a focus on automation for agility, programmability, and orchestration. This is really, I guess, what we could call, broadly speaking, the SDN era, and it, obviously comprising network virtualization as well. One thing that's interesting about this, I think, and bears mentioning, is that it's not just technological generations at play here. There's a human factor to this as well, and I think it actually accelerates some of these changes. It is very generational in its effect. We move to the next
Brad,
slide.
if I could jump, Brad, if I could jump in here.
Yeah, absolutely, absolutely.
I just wanted to make the observation that in our business, we agree with your view about the third platform, with one subtle exception, and that is, I don't think that moving ahead, people can really think about or consider networking and security as separate disciplines. So we would argue that next-gen security actually be incorporated into your third platform because it's so integral to the path ahead.
It's a great point, Jeff, and absolutely I can see how you would say that and why you would say that. I think, increasingly we are seeing the network and security become, indivisible. It probably always should have been that way, but we're definitely seeing that progression in the marketplace. Now we're looking at, we talked about this being a period of SDN and network virtualization. Today we see, a number of use cases. These are three that we've called out that are fairly prominent. There's business and operational agility, all about automating and accelerating the provisioning of the network and speeding time to value in terms of supporting the applications that generate revenue and opportunity for organizations. There's security, which is right up there as a major driver. And you're going to see some data from some SDN surveys that we've done. In the form of micro-segmentation to provide east-west security in the data center, and definitely there's a lot of innovation in security analytics as well, and it's becoming increasingly important to not only application security but application uptime and availability. And also another area is business continuity and disaster recovery. These are all significant use cases. There are others as well. The drivers, of course, coming back to what's happening with the third platform and especially cloud, and you've got, of course, a lot of increased virtualization within the data center as well, pushing things along. So as we move to the following slide. And here we go. Here's the survey data that I was referring to. This is from an SDN survey that we just did last fall. Went out worldwide again with this survey, and we asked, if you are implementing SDN, which of the following factors is the primary motivation? And just so you're clear, the dark blue is from over-the-top cloud providers, so not CSPs, but cloud providers. And the light blue is representative of enterprise respondents. And we can see that in the enterprise respondents sector, improving security in the data center through mechanisms such as microsegmentation was #1 in terms of the primary motivation. Yes, there's also, of course, a concern among enterprise respondents with needing the network to have greater agility to support virtualization in cloud, and also requiring better automation and programmability for overall operational efficiency. But #1 in terms of the responses was improving security. So very interesting, again, to see security called out very prominently in this context. If we move to the next slide. And as I said earlier, these changes that are occurring right now as a result of digital transformation and the third platform in cloud are not only occurring in the data center, they're occurring right across the network, across the campus, and also across the WAN. So WAN transformation is occurring as well. And use cases that are driving that, there's a lot of proliferation of collaborative applications, UC&C apps, as well as video conferencing. Some of these are cloud-based. And that brings us to the second point, which is optimizing access to cloud services, including popular SaaS services and other cloud services. They're also looking at, as they leverage different networks across the WAN, simplifying deployment and provisioning of branch sites and the applications that reside there. And again, security, very much a factor as enterprises look across their WAN and they look to enable rapid responses to security threats and vulnerabilities. And if we move to the next one. Just a little bit more on WAN challenges. This is from a brand new SD-WAN survey that we did. And we asked about today selecting the top WAN challenges that relate to your organization or company. And right up the top, you can see security requirements, basically outflanking #2, cost-effective delivery of SaaS and other cloud services across the WAN, management of connectivity, in other words, simplifying the complexity of connectivity at remote branch offices, and so forth down the list. But security, just as it is in the data center, just as it is certainly in the campus, is a foremost consideration and concern across the WAN. And if we move to the next slide.
Hey, Brad, before you go ahead, I wanted to make a couple points. I wanted to jump in and make a couple points about that you'd made, which I completely agree with. And it's interesting here, if you talk about the top WAN challenges, and then within the context of some of your comments about primary use cases for SDN and network virtualization, most of the approaches to microsegmentation and SDN are really data center centric. They focus primarily on east-west traffic. But when this slide here points out people's, or really users, enormous focus on what could generally be construed as north-south traffic. And so I just wanted to make the point that the tempered network solution is equally capable of microsegmenting east-west and all north-south traffic. So it's quite a bit different than the other traditional approaches to solving those problems.
Right, and it's not an either-or consideration. It's a great point because they're still going to have, of course, north-south traffic. Obviously, they're going to have applications that basically flow north-south. You're going to have more east-west traffic as well, and you've got to address both. So totally understand. In this slide that's following, we asked specifically about SD-WAN solutions. I think many of you, of course, are now familiar with them. They've received a lot of hype in the marketplace, a lot of attention, and rightly so. The WAN is, as we pointed out, having to be re-architected and operated in a totally different way based on a lot of the new workloads, specifically in the cloud. But we asked about the SD-WAN components that are considered most important in selection of an SD-WAN solution today. And again, right up top is the security capability. really quite outstripping all the others. You look at 58.3% of respondents to the survey called that out. WAN optimization also very healthily represented in terms of WAN optimization and acceleration technologies. But it's a big drop off after that to policy control and management, and even things like automation, which are also very important in this context. So again, tremendous representation for security in terms of being a critical component for any SD-WAN solution that customers adopt. If we move on to the following slide. One of the things that is happening with SDN, and this diagram here comes from what we call a planscape that we wrote just in the last few months. And we were really looking at enterprises who are, in their mind anyway, struggling with a lot of the complexity associated with SDN. And we wanted to provide sort of guidance on, why, so they could articulate it within their organization to stakeholders, to their bosses, to executives in the firm about, why they're doing it, what it entails, who needs to be involved, and, how they need to proceed. But one of the things that's really come through to us in our conversations with customers is that there's still a lot of perceived complexity, not only about the technologies, but about the operational models. And that brings us actually to my next slide. I think, we've reached a point where we're getting to definitely needing to bring an end to network complexity. I think for a long time in the industry, there was almost, something akin to, and I don't want to overplay it, but something akin to a conspiracy of complexity where, vendors and customers sort of had a mutually reinforcing relationship where vendors would add support for proprietary protocols or proprietary implementations of industry standard protocols, or adding more features and functionality and more complexity to their products. And customers embraced it because customers also wanted to be the masters of complexity, and they saw it as basically providing a guarantee of job security. But we've reached a point with all the factors that I went through before: digital transformation, the need for agility, the move to cloud. There's more and more demands being placed on the network and the network professional, and there's primarily a real demand for agility and flexibility. So that old, conspiracy of complexity really has come to its end. It's come to the end of its usefulness for both vendors and customers. So amid all this disruption, it no longer is tenable. More is being asked of the network, more is being asked of network operators. You've got architectural changes, operational changes. You have to acquire new skills in many cases. And it's being asked of you now. You've got to move. The skills gap means ease of technology consumption, deployment, and operation will matter more than ever, and I think for the next several years. So vendors, really, it's incumbent upon them to help to ease this complexity burden that customers face. We've come to a point where it's absolutely essential. And that brings me to my next slide, where I'm going to wrap up. I think, in terms of essential guidance from IDC, digital transformation, which is predicated on the third platform, is a critical enterprise imperative worldwide. We're seeing it right across the board, regardless of vertical industry, regardless of geography. Network transformation, including a focus on increased agility and greater security, is a key requirement in this evolution. So the network has to be transformed as well. SDN was an architectural response to these new requirements, and really, unlike a lot of technologies, it came initially from customers themselves rather than from vendors. Not to say vendors haven't gotten involved and made a contribution there, but initially this was a customer-led phenomenon. And I think SDN solutions and networking solutions in general must become less complex. They have to be easier to deploy, simpler to manage, and certainly from a cost of ownership standpoint have to become simpler as well. So that's the end of my part of the presentation. I want to hand it back to Elaine now.
Thanks, Brad. Great point. Now we're going to hand it over to Jeff Hussey, CEO of Tempered Networks.
Well, thanks, Brad. I can't agree with you more on a number of the points that you made, especially with respect to complexity. It's the thing that is stopping so many people from really moving their network to where they need to be, and reducing complexity is one of the keys to our solution. What we're doing to address that complexity issue is really fundamentally changing the way people deploy networks. One of the points I made earlier in the presentation was that it's our belief that people can't any longer treat security and networking as independent disciplines. And so what we've done is take that and productized it with an approach we refer to as identity-defined networking. We fixed the broken trust model that exists in TCP/IP and marry that with an orchestration engine that frees staff from the complexity that Brad so clearly articulated. We help people create one-hop end-to-end networks without using any of the common tools that are so difficult to deploy, much less maintain on an ongoing basis: firewalls, VPNs, VLANs, access control lists. And as just a natural part of our orchestrated deployment, you get micro-segmented networks that cross hybrid networks, whether they're physical, virtual, or cloud-based. How we do that is using a new protocol. It's called Host Identity Protocol, and it was developed initially by the Navy to secure drone command and control, and was later built into a solution at a large aerospace company. What we've done at Tempered Networks is commercialize that solution, and we're bringing it to market. How it works is pretty simple. What we do is we use the protocol, Host Identity Protocol, and we build it into our application stack that can be deployed using software or an appliance gateway, and deployed at the perimeter, physical or logical, of a network. And it creates an identity-defined fabric. It's a drop-in, bump-in-the-wire solution that can go anywhere. And when those gateways that we refer to affectionately as hip switches are defined, combined with an orchestration engine, very explicit, whitelisted, encrypted channels of communication are established across this fabric. And so what we do is we replace the spoofable IP addresses with unique cryptographic identities, and we completely assume the responsibilities of PKI and Certificate Authority Management, and enabling our users to really scale this to tens or hundreds of thousands of devices. Very simply, this using Host Identity Protocol, or HIP for short, we create these authenticated sessions or tunnels between legacy devices that connect directly to our gateways. And this is what creates the trusted identity-defined network fabric. You'll see the icon on the slide called the Conductor. That's our scalable orchestration engine. And in that orchestration engine, it's either by use of a single pane of glass management interface or an API, all of the establishment and maintenance and changes of trust policy between legacy devices can be easily managed. So what we do is we're a direct antidote to the complexity that Brad referred to. A single pane of glass management interface that's really intuitive, and it's error-free. Despite us being a relatively young company, our product is very mature because we're commercializing and building on work that's occurred over about 15 years. There is no way within our user interface to establish asymmetric policies. So we're very accurate when we say it's mistake-proof. The notion of a 3-click network design are not even our words. Those are the words of our customers who have used our products to establish networks and build trust between hundreds and thousands of devices in a very small number of clicks. And further to that, with our automated API, we can set up scenarios where the orchestration engine does prepackaged actions depending upon what's going on within a network. And I'll spend a few more minutes on that a little bit later. Here's a picture of the user interface. Very simple and intuitive. It shows what's online, what types of things are up and what aren't, and a variety of different versions. But what's really important is on the right-hand side of the screen, which is what we call the visual trust map. And that basically is a graphic representation of your trust policy or your security policy. It can be a simple hub and spoke network, a partial mesh, or a full mesh, depending upon what your requirements are. An example deployment suggests a typical flat corporate network that could involve a number of different transport mechanisms. You could have an MPLS network, you could have clouds, you could have a disaster recovery site, cellular attached users, or whatever you can think of. What we do is we install our HIP switches as gateways, either as an appliance, as a piece of software on a laptop or other device, or an instance in the cloud. And then the orchestration engine establishes the policy within the overlay network. For example, the devices in orange only know that other devices in orange exist. They can't see anything else. And same for the devices that are connected in purple. The orchestration engine uses a whitelist, and only explicitly trusted devices know the others exist. Example use cases are shown here to secure distributed endpoints. It's a very common use case for us, regardless of the device. It could be an ATM, it could be a kiosk, it could be a medical device, it could be parts or tools on a manufacturer's floor. Application segmentation is another common use case for us. This is a good example of what might happen in a data center where different customers or different applications use common segments but still need to be encrypted and segmented from each other. That's something that's very simple for us to do. Vendor or third-party remote access is a very challenging security problem in many, many networks. And we do a very simple and graceful job of that. For example, you can take a manufacturer or a large utility that might have hundreds of devices scattered over large geographic areas, and the utility only wants to provide specific access to a vendor to their devices on a network. And we can do that using our software-based or our appliance-based HIP switches. Here are pictures of our product line. You'll notice that there's a couple devices on the top that are smaller. Those are industrialized form factor appliances that can go in wide temperature ranges and meet a number of common certifications. And then we also have data center grade platforms and our orchestration engine, which can be either appliance-based, run on a virtual machine, or be deployed within the cloud. So really, in summary, what our identity-defined network does is give state-of-the-art, best-of-breed security, end-to-end encryption, device-based whitelisting, and microsegmentation. And it's all managed through a single pane of glass user interface or an automated API. Our solution gives people this state-of-the-art, best-of-breed security at a third the cost of competing approaches, and with much less risk and much less complexity than any other solution can provide. So happy to take questions at this point, and if anyone's interested, we'd be delighted to send you a copy of a book that's actually written about our solution called HIP, The End to Hacking as We Know It.
Thank you, Jeff. Brad, do you have any comments before we open it up to questions?
I think Jeff did an excellent job covering the technology and its applicability to enterprise requirements today, and covered the use cases, covered the application scenarios. I think it was a great presentation.
Great, thank you. So with that, we will open it up to any online questions from the audience. We'll give folks a minute.
Wonder, Jeff, while we're waiting for some questions to come in, you've obviously you've had a number of early customer engagements. Wonder if you could talk about some of the early customers you're seeing in terms of a customer profile. Are they coming from a range of vertical industries? What about company size as well? I wonder if you could give us some insights into some of your early customers.
Well, I'd be happy to. It's a great question. In terms of company size, it's all over the map. We have Fortune 100 customers and then small municipal utilities within our customer base. But I'd have to say that our current customer base now is really reflective of the original use case of the technology, and so it's more industrial and or utility focused. So electric utilities, oil and gas production and distribution, fresh and wastewater utilities, but increasingly what we're seeing are a much more classic enterprise type of customer. We have banks who are securing their ATM infrastructure or online banking infrastructure. We have airlines and hospital systems who are securing their networks of medical devices. We have a large number of engagements in military applications and other governmental applications. So it really runs the gamut. The important point is that what's happened over the past few years are that networks of things, whatever they are, have moved from a traditionally separate, call it air-gapped network, and converged onto more traditional corporate enterprise networks. And so those devices which used to be isolated aren't any longer, and every single one of those devices provides a pivot point onto a corporate network, and those things really need to be secure. And corporate or traditional IT staff just simply don't have the bandwidth to do that using conventional methods. And that's what's really driving the growth of our business and the adoption of our solution.
Okay, so we do have a couple questions that we'll answer. The first one here is, do you have redundant or distributed conductors?
Yes, the conductors can be deployed in an HA configuration, and they don't have to be, and they can be distributed. They don't have to be together.
Great. The next question is, what security do you have for the conductor?
The conductors have the same security as our HIP switches. They speak HIP, and but we routinely get that question, and it's a good one. The best security model for the conductor is to understand how it works, and that is, it's only functioning when it's pushing policy to the HIP switches that are on the network. And so there are highly sensitive customers who simply turn their conductor off and or disconnect it from the network when they're not pushing or updating policy. That's the most secure means. But if you want to keep it connected, we use all the traditional tools to secure devices.
Next question, how do you secure the hardware from hacking?
The HIP switches themselves, the gateways, there's no access to the gateways. They can only be communicated to by the conductor through a trusted HIP-based connection. Any other connection attempt is simply dropped on the shared interface.
Next question, do you have a specific use case for utilities who offer automated meter reading or SCADA systems?
Securing SCADA systems on either a dedicated or a shared network is our largest use case within our installed base. So you can imagine a county government. In county governments, typically the county IT department maintains the shared infrastructure that's used by, in the case of the county where we're located, the property tax system, the sheriff, the library, and the water and wastewater systems. I, for one, don't care if the property tax system goes offline, but I'm acutely sensitive to not having water or wastewater services. So what we've done in many counties is help those utilities that really are critical isolate and encrypt their communications across that shared infrastructure.
Any other questions? One more came through. Okay, there's somebody's inquiring about use cases for SCADA network security for power and water production and distribution. Maybe, Jeff, I don't know if you want to elaborate. We can certainly follow up with that gentleman, but if you want to elaborate on any of that now, we can.
Yeah, as I mentioned before, we have a great deal of experience in securing SCADA networks across all industries. Gas and oil pipelines, natural gas distribution networks, freshwater, wastewater, electrical substations, and other kind of electric distribution networks. We have customers who are evaluating our technology within the context of it being applied to end devices themselves. That would be an example of which would be an IP camera or a smart meter. One of the attributes of our technology that differentiates it from other potentially competing approaches like SD-WAN is that our HIP switch gateway is very, very lightweight. And so we can put it anywhere. We can put it on an IP camera. We can put it on a sensor. It will fit in anything, it'll fit in, all it requires is the equivalent of about an ARM9 processor and 64 megabytes of memory. And so that allows us to extend our identity-defined network fabrics really anywhere.
Great, thanks, Jeff.